Good afternoon, everybody. So we are going to start the lecture to continue from where we left off for this week. Hopefully that we can finish with regard to the numbering systems, and then after that, next week we try to do some revision on the analog electronics to prepare you for the test one. Most probably that test one we will do in official week 7, when we start the what do you call it, in after Raya lah, we do the test one. Okay, and okay, I'm going to start to share the slides. I'm going to share the slides, desktop, application window, slideshow. Okay. So anybody, everybody see this? Okay.
Yes, sir. Can, sir.
Okay. Last Tuesday, we go through the numbering systems, which is decimal, binary, I think decimal and binary only, right? So now we are going into the binary arithmetics. How we are going to go through the rules of binary arithmetics. First one is that the binary addition. So how do you add binary digits, or binary, or how do you add bits? Binary digit is called bits. So there are 4 basic rules for adding binary digits. There are as follows: 0 add to 0 is equal to 0. So basically the sum is 0, the carry is also 0. When you add 0, you add 1, and the sum is 1 and the carry is 0. When 1 add to 0, so the sum is 1, the carry is 0. When 1 add to 1, the sum is 0 and the carry is 1. So you write 1, 0. Clear in terms of the basic rules for addition, binary addition.
Yes,
Okay?
sir.
So,
Yes.
so if you look at the example, if you have 0, 1, 1, you add to 0, 0, 1. So what you do is that you set up
100.
so you set up this for the calculation, that first you write 0, 1, 1, and the second number is 0, 0, 1. So you add. So 1 add to 1 is, the sum is 0, and you have the 1 as a carry. So carry, add to 1, and add to 0. So basically that is 1, 0. So the sum is 0. So you have a carry of 1. So the carry add to 0 is 1. Add to 0 is 1. So the answer is 1, 0, 0. So if you want to check whether it's correct or wrong, so you can do, you convert into decimal, which is 0, 1, 1 is 3, and 0, 0, 1 is 1. So 3 add 1 is 4. 4 is 1, 0, 0. So yes, this is correct. Okay. Clear? Simple.
Sir, ulang balik 3 dengan 1.
This one. This one.
Yes, sir. Yes, sir.
So this 3 is actually this in binary. 0, 1, 1 is 3 in decimal. And 0, 0, 1 is 1 in decimal. From the last lecture.
Okay, sir. Okay.
How do you know do you know how to get these three?
Yes, sir.
Yes, sir.
1
1
times
to the
2 to the power of 0.
0.
This is 1 times 2 to the power of
To the power
of,
1.
of 1. So this is 2, this is 1. So 2 plus
1.
1
2
is
plus 1,
3.
3.
Okay. So now, when there is a carry of 1, we have a situation in which 3 bits are being added. This situation is illustrated as follows. For example, when you have the carry, like just now, 1 at 0, so the answer is 0, 1. So basically the sum is 1 and the carry is 0. When 1 at 0 at 1 is 1, 0. So the sum is 0, the carry is 1. 1 at 1 at 0 is 1, 0. So the sum is 0, the carry is 1. When you have 1 at 1 at 1, so this is actually 1, 1. So the sum is 1 and the carry is 1. Okay, clear this rule.
Sir, sir.
Okay, so
Aku rasa macam kau under hospital lah. Clear. Clear.
siapa tu? So let's say that you have a decimal, 5 plus 6. So the answer is 11. So if you want to do it in binary, so 5 you convert into binary is 1, 0, 1. And 6 convert into binary is 1, 1, 0. So how do you add this? 0 at 0, 1 at 0 is 1, no carry. So 0 at 1 is 1, no carry. So 1 at 1 is 1, 0. The sum is 0, the carry is 1. So the answer is 1, 0, 1, 1. Easy, right? Now, the second example. Let's say you have a decimal of 15 and 20. You want to add these two numbers. So the answer is actually 35. So if you do it in binary, so 15, you convert into binary is 1, 1, 1, 1. Whereas 20, when you convert into binary is 1, 0, 1, 0, 0. Then you add 1 at 0 is 1, no carry. 1 at 0 is 1, no carry. 1 at 0 is 1, 0. Basically that 0 is the sum with 1 carry. So the carry at 1 at 0 is 0 with 1 carry. So 1 at 1 is 0 with 1 carry. So the answer is 1, 0, 0, 0, 1, 1. So this is actually 35 in decimal. Now, let's say you have this 3.25. You want to add to 5.75. So in decimal, it's 9.00. So if you convert 3.25 into binary, you get 1.01. And 5.75, if you convert into binary, is 101.11. So when you do addition, so just the same as whole number, you start from the back. 1 at 1, 0 with 1 carry. So the carry at 0 at 1 is 0 with 1 carry. So 1 at 1 is 1, 0. At 1 is 1, 1. So 1 is a sum with 1 carry. So 1 at 1 is 1, 0. At 0 is 1, 0. So 0 with 1 carry. 1 at 1 is 0 with 1 carry. So the answer is 1001.00. So this is actually 9 in decimal. Any question? Easy. Now you go into subtraction, binary subtraction. The 4 basic rules for subtracting bits are as shown in the highlighted box there, in the yellow box. So 0 subtract 0 is 0. 1 subtract 1 is 0. 1 subtract 0 is 1. If it's 1, 0, subtract 1 is 1. If 0 subtract 1 with basically that this with a borrow 1. Basically minus 1, borrow 1. So for example, you have two numbers. You want to subtract 0, 0, 1, 1, 1 from 1, 0, 1, 0, 1. So you set up the calculation like this. First is the number that you want to subtract from. It's 1, 0, 1, 0, 1. And this is the number that you want to subtract. 0, 0, 1, 1, 1. So how do you do that? So start from the back. 1 subtract 1 is here is 0. Okay. 0 subtract 1 cannot. You have to borrow 1. So you borrow from here. You borrow 1, then this is becomes 0. And this become 1. Right? Right? Right?
Yes, sir.
Yeah.
Okay, sir.
Okay lah.
So 1, 0 subtract 1. Now this actually become 1, 0 because you borrow 1. So 1, 0 subtract 1 is 1 here from this 1. So here is now is 0. You cannot subtract 1, so you need to borrow. So you borrow from here. Okay? You borrow from here, cannot because you have to borrow because you cannot borrow from 0. So you borrow from here. So this is become 0, this become 1, and 1 is here. So now it's 1, 0. 1, 0 subtract 1 is 1. Okay. Over here, you have 1. 1 subtract 0 is 1. This is 0 subtract 0 is 0. So the answer is 0, 1, 1, 1, 0. So basically that you have, if you want to check, you do in the decimal 21. This is actually 21 minus 7. So it's 14. So this is 14 in binary. Okay. Clear for this part.
Yes, sir.
Okay.
Oh, tapi sir, kalau dipinjam semua jadi 10 kan sir?
Yes, because it's 2. 1, 0. Bukan 10, 1, 0.
Oh, 1, 0. Okay.
Yes, 1, 0. It's not 2. It's not 10. It's 1, 0. 1, 0 is 2 in decimal. Okay, now let's say if you have this decimal 9 subtract 5 minus 5, so you get 4, and you want to do this in binary. First, you convert 9 into binary, which is 1001, and you convert 5 into binary is 101. So you set up this. So now you can subtract 1 subtract 1 is 0. 0 subtract 0 is 0. 0 subtract 1 cannot. So you have to borrow. So you borrow 1 from here is 1, 0. 1, 0 subtract 1 is 1. And this is 0. So subtract 0 is 0. So the answer is 0, 1, 0, 0. Clear?
Yeah.
Okay. Second one. Decimal 16 minus 3. So becomes 13. So in binary, 16 is 1, 0, 0, 0, 0. And 3 is 1, 1. So you set up this equation, then 0 subtract 1 cannot. You have to borrow from here, cannot. Have to borrow from here, cannot. You have to borrow from here, cannot. You have to borrow from here. So here becomes here is 1, goes here is 1, goes here is 1. So here is becomes 1 0. 1 0 subtract 1 is 1. And over here actually 1 because you borrow just now. So this is 1. 1 subtract 1 is 0. And over here is 1. Subtract 0 here is 1. 1 subtract 0 is 1. And this is actually already 0. So 0, 0 is 0. So the answer is 0, 1, 1, 0, 1. So it's 13. Okay? You see the calculation, the method?
Yes, sir.
So the third one, in decimal, you have 6.25 subtract 4.50. So the answer is 1.75. So you convert first. You convert into binary. 6.25 is 110.01 and 4.50 is 100.10. So you set up this equation. So basically that now 1 subtract 0 is 1. 0 subtract 1 cannot. You have to borrow. You borrow from here. So it's 1 0. 1 0 subtract 1 is 1. So okay, basically that here actually you just borrow from here just now. So this one is now is 1 because this one borrow from here cannot. They borrow from here. So this is 1. They borrow here. So now it's 1. 1 subtract 0 is 1. This is 0 just now. 0 subtract 0 is 0. 1 subtract 1 is 0. So the answer is 001.11. So this is actually 1.75. Okay, clear?
Sir,
Yes.
maknanya kalau pinjam 2 tu yang tadi saya tunjuk tu kan? Yang tu kan, yang lepas titik kan dah pinjam 01 tu kan, maknanya kalau pinjam lagi tak apa
Memang kena pinjam kat sini. Dia macam biasa aja. So macam tadi juga. So basically that here 0, 1 you cannot subtract. So you have to borrow from here. You cannot borrow. You borrow from here. So when here move here become 1 0. So this is actually now you have 1 0 here. So this one is borrow from here. So 1 0 you got 0 and this one you got 1 0. This is 1. Okay, clear? Now, we have done this addition. We have done the subtraction. Now it's multiplication. So this is how when you want to multiply two binary numbers. The 4 basic rules for multiplying bits are as follows. 0 multiplied by 0 is 0. 0 multiplied by 1 is 0. 1 multiplied by 0 is 0. 1 multiplied by 1 is 1. So, if we multiply 1101 multiplied by 1010, so you set up the working like this. Okay. So basically that 101 is 13. 1010 is 10. So if you multiply, your answer will be 130 in decimal. So now we do it in a binary. So what do you do first? Just like how you multiply in decimal, you start from the back. So 0 multiplied by 0 by 1 is 0. 0 multiplied by 0 is 0. 0 multiplied by 1 is 0. 0 multiplied by 1 is 0. Then you shift the second one. So this one, 1 multiplied by 1 is 1. 1 multiplied by 0 is 0. 1 multiplied by 1 is 1. 1 multiplied by 1 is 1. Then you shift to the next one, this 0. 0 multiplied by 1 is 0. 0 multiplied by 0 is 0. 0 multiplied by 1 is 0. 0 multiplied by 1 is 0. Then you shift to the last one. 1 multiplied by 1 is 1. 1 multiplied by 0 is 0. 1 multiplied by 1 is 1. 1 multiplied by 1 is 1. So now you have this. What you do is you add 0 is 0 because didn't add with anything. 0 add 1 is 1. 0 add 0 add 0 is 0. 0 add 1 is 1. 1 add 0 is 1. 1 add 1 is 1, 0. So the sum is 0. The carry is 1. So 1, the carry at 1 is what? 1 at 1 is 1, 0. Okay, 1, 0 at 0 is 1, 0. 1, 0 at 0 is 1, 0. So the sum is 0, the carry is 1. So 1 at 0 is 1. 1 at 1 is 1, 0. So 0 with the carry 1. 1 at 1 is 1, 0. So 0 with a carry 1. So the answer is 1, 0, 0, 0, 0, 0, 1, 0. So if you convert this into decimal, it's equivalent to 130. Okay, clear? On the multiplication.
Yes.
Simple. Okay.
Yes, sir.
Okay, now you want to multiply the decimal, the fractions in binary. So let's say you have 101.101 multiplied by 110.01. So if it's in decimal, so you have 5.625 multiplied by 6.25. So the answer is 35.15625. So the method is still the same. So you use the same way, setup, and you go bit by bit, starting from the left. The first one, and the second one, the third one, the fourth one, and the fifth one. Then you add. You add. Then after that, you count how many bits, the total, how many bits on the left, on the right of the of this point. So in this case, 1, 2, 3, 4, 5. So you take from here 1, 2, 3, 4, 5. Then there is the dot. So the answer is 100,011.00101. Clear? You try to work it out on your own after this. So it's just the same thing like you did for the like you do for this decimal. Then the last one is the division. Division in binary follows the same procedure as division in decimal. 0 divided by 1 is 0. 1 divided by 1 is 1. So, for example, if you want to divide 1100 divided by 100, so you set up like this. 1100 divided by 100. So 1 cannot, 1 cannot. So basically you take 110. So 110 is basically 1. 100. So you subtract 110, subtract 100. So you get 0, 1, 0. So the last 0 here. So you have 100 divided by 100. You get 1. It's 100 with a remaining of 0, 0. So the answer is 1, 1. So if you want to check, 1100 is 12, 100 is 4. So 12 divided by 4 is 3. 3 basically in binary is 1, 1. Okay. Clear, simple. So now, let's say you want to divide. 11011 divide with 101. So you set up this division. So 110 divided by 101, you get 1. 100, so the remaining is 0, 1. So 0, 1, take this one. So it's 0 because you cannot divide with that. So 0, 0. So the remaining is 1, 1. And you bring this down. So you have 1, 1, 1. 1, 1, 1 divided by 101 is 1 with the remaining of 1, 0. So the answer is 101 with a remainder of 1, 0. So if you divide this in decimal, it's 11011 is 27, 101 is 5. So the answer is 5.4. So this is 101 is 5. 4, basically that 0.4 is the remainder. If 0.4 divided by times 5 is what? 2. So the remainder is 2. So the answer is 5 with a remainder of 2. Okay. Now it's assigned numbers. Somebody asked me, how are we going to indicate in binary that number is a negative number? So in this case, we call it a signed number. So we use a sign bit to indicate whether the number is positive or negative. So when a sign, this is in the form of sign magnitude form. You have a sign and you have the magnitude. So when S sign a binary number is represented in sign magnitude, the leftmost bit is the sign bit. So there is one bit, it's a sign bit, which tells whether the number is positive or negative. And the remaining bits are the magnitude bits. So in this case, for example, you have 000110001. If I say that this is a sign magnitude form, therefore you know that the most significant bit is the sign bit. And the remaining bits are the magnitude bits. So what does this signs indicate? If it's 0, it's positive. If it's 1, it's a negative number. Okay. For example, if you have 000110001 in a sign magnitude form, so this is actually what is 0. 0 is a positive number. And what is 0011001 is 25. So 25, positive 25. If the sign is 1, 0011001, then the number is minus 25. Okay, clear? Very simple. If the question says that it's a sign magnitude form, then you know the first bit is the sign bit. The most significant bit is the sign bit. And the rest are the magnitude bits. Okay. Another form of sign numbers is using the complements. 1's complement and 2 complements. So you can represent a signed numbers in 3 ways. Sign magnitude form and 1's complements, also in 2's complement. The 1's complement and the 2's complements of a binary numbers are important because they permit the representation of negative numbers. These complements are used to simplify the operation of subtraction in digital computer by replacing the operation x minus y with the operation of x plus minus y. What is the first complement? The first complement of a binary number is found by changing all the 1's to 0's and 0's to 1. That is the 1's complement. You just reverse. You change the number. For example, a binary number of 10110010. So the first complement is you change into the opposite. If it's 1, change to 0. If it's 0, you change to 1. If it's 1, change to 0. 1, change to 0. 0, change to 1. 0, change to 1. 1, change to 0. 0, change to 1. So therefore, the ones complement of this binary number is 01001101. That is the ones complement. Simple. When I say it's a first complement or ones complement, you just change ones to 0, 0 to 1 of that number. Clear? Two's complement.
Yes, sir.
A two's complement of an n-bit binary number is obtained by subtracting the number itself from 2 to the power of n. So a is equal to 2 to the power of n minus a. Example, if a is 101101, so the two's complement of that number is a. Actually, what is the power of n? How many bits you have? 2, 4, 6. So a is actually 2 to the power of 6 because you have 6 bits. So a equal to 2 to the power of 6 minus a. So what is 2 power of 6 is 100000 minus 101101. So the answer is 010011. So this is the 2's complement of this number. There is the 2's complement of the number. Example, express the decimal number minus 39 as an 8-bit number in sign magnitude, in 1's complement and in 2's complement. Solution. First, if it's positive 39 is actually 00100111. This is actually you use the conversion from the binary, from the decimal to binary, which we learned in last lecture, right? So this is the number, 0100110. So 2, 4, 6, 7, 8. So this is positive 39. So if negative 39, you change the sign bit into from 0 to 1. So negative 39 in sign magnitude form is 10100111. Okay. In a ones complement, basically that you take this the sign magnitude form. You you take this what we call it, this number, this part, this number, and you inverse. 0 change to 1, 1 change to 0, 0 change to 1, 0 change to 1, 1 change to 0, 1 change to 0, 1 change to 0. So the number 1101100 is the ones complement of minus 39. So minus 39 is produced by taking the ones complement of the positive 39. So you see this? Positive 39, okay, here. So basically that you inverse. Okay, the sign also inverse. Nampak tak? See? This. Compare this with this. So basically that you just reverse. 0 to 1, 0 to 1, 1 to 0, 0 to 1, 0 to 1, 1 to 0, 1 to 0, 1 to 0. Okay? So that is the
Oh my.
ones complement. Now, the easiest way for you to do two's complement is the easiest way. Instead of using instead of using this, basically, oh, how come I skip this one? So this is actually another way. This is a simple rule of doing the 2's complement. It's basically that 1's complement plus 1. So this is another way. So this is the first difficult way, and this is the simpler way of doing the 2's complement. So this example, let's say you have this binary, so you take the 1's complement and you add 1. So this is the 2's complement of that number. So how come I missed that one just now? So for this example, the 2's complement of minus 39 is basically you take this 1's complement and you add 1. So you get 1101101. So minus 39 is produced by taking the 2's complement of plus 39. So if you take the 2's complement of this, you get this because you add 1. Okay, clear? This will be in the test normally. So summing the weights where there are, okay, this one, okay, how come it's jump? Okay, example 10, okay, determine the decimal values of the signed binary numbers expressed in 1's complement. Let's say you have A 0001011. So how are you going to determine the values in decimal of the signed binary numbers? So basically that we will tell you whether it's a signed numbers or not. So in this example, we tell you it's a signed binary numbers expressed in 1's complement. So we tell you this is really in 1's complement. If we don't tell you, you will not be able to determine the decimal values. So we, in the question, will tell you what is this number, whether it's a signed magnitude form, whether it's a 1's complement, or whether it's 2's complement when we are dealing with the signed numbers. So in this case, it's a 1's complement. So when 1's complement, so this is the sign. The sign is positive, 0. And this is the, what do you call it? The number. So this is positive, this is the number. So therefore, you sum all this. So this one is 1 times 2 to the power of 0 is 1. 1 times 2 to the power of 1 is 2. 1 to the power times 2 to the power of 2 is 4. And 1 times 2 to the power of 4 is 16. So this number is 23. This is number 23. Right? Okay.
Sir?
Yes.
So yang soalan ni dalam binary number ke first complement dah ni? Yang A tu.
Then you see this? What is all? Determine the decimal values of the signed binary numbers expressed in 1's complement. So this numbers is expressed as 1.
First complement dulu
This one,
Ha.
you tak payah tukar because since the sign is 0. The sign is positive number.
Oh, jadi apa maksud dia ni express in first complement tu?
So basically that if this number, if it's 1 here, then this is in first complement. If it's 0, basically this is actually in sign and this is the magnitude. Here. Okay.
Yes,
And here, if it's positive, it's like this. You do the first complement when it's negative. you do the complement when the number is negative. So you do whether first complement or one's complement or two's complement. You don't do complement when it's positive number. Okay. So this is a positive number. So the positive number is basically the sign and this is the magnitude. Even though the question said that sign binary number expressed in one's complement. What about this one?
The first complement.
This one, because the sign is 1, so basically it's a negative number. So then negative number, then this is actually in one's complement. Okay, this negative number, so it's in one's complement. Okay. Clear? So 111010000. So this is a negative number. So we sum the weights where there are ones. So this 0, 0, 0. So 1 times 2 to the power of 3 is 8. 0. 1 times 2 to the power of 5 is 32. 1 times 2 to the power of 6 is wait. 5 is here, is 64. 1 times 2 to the power of 6 is 128. So minus 1. So this is the minus sign. So you add. So you get minus 24. So adding 1 to the result, the final decimal number is minus 24 plus 1 is minus 23. True or not? Minus 23. True or not?
Assalamualaikum, sir.
Waalaikumsalam.
Yang 2 power of 7 tu just negatif, sir. Tak kira.
Ini Syahrizwan ke?
Ya, sir. Sorry, masuk lambat, sir.
Welcome.
Ya.
Tapi suara saya cam lah.
Okay, sir.
Okay.
So 2 power of 7 tu dia tak kira, sir. Dia just negative number kan? Dia just sign negative. Okay.
Sign negative. That's to indicate the sign. Right? Okay. So this is actually, to me, a more difficult way. Most probably that there is what we call it, an easier way how to calculate. Yeah. Try to do this. You take this number. Okay, try to take this number. 11010000. Try you take one's complement. So you get 0, 0, 1, 0, 1, 1, 1. Betul?
Betul.
Try. So you have 1, 1, 1, 0, 1, 0, 0, 0. And the sign 1 you discard. And you left with 1, 1, 0, 1, 0, 0, 0. And you take one's complement. So one's complement is 0, 0, 1, 0, 1, 1, 1. And convert this into decimal. So you get 1 plus 2 plus 4 plus 16, right? Right?
Betul, sir.
Right?
Dapat,
So,
betul, sir.
16 plus 4 plus 2 plus 1. How many? You get
23.
23. So the decimal number is actually minus 23. So that is actually a faster way of doing that.
Shortcut.
You don't have to do this, calculate this, and then after that add 1. No, you just inverse this. You discard this because this is telling you the negative, and this is telling you the one's complement. So you change this back into the original one. So how to do that? You reverse. This is 0, 0, 1, 0, 1, 1, 1. So 1 plus 2 plus 4 plus 16. So equal to 23. And the sign is negative. So negative 23. If you do that, I accept also the answer, the solution in the test. Because that is the easier way and the fastest way of doing it. Okay?
Okay, sir.
Most probably I will update the slides. Right?
Sir, kalau
Yes.
dia negatif sign je kalau last one sir.
This. When
Yep.
it's negative sign, and it says that it's a ones complement, so basically this is the ones complement. If it's positive sign, this is not complement. This is actually the magnitude, just like here. Okay, this is the magnitude. Positive and magnitude. Ones complement, when you have this, if it says expressed in one complement, actually, this is the sign, this is the ones complement. Okay. Second example. Determine the decimal values of the signed binary numbers expressed in two's complement. So now you have 0, 1, 0, 1, 0, 1, 1, 0. So the solution is that, okay, this is a positive because it's 0. So therefore, this is the magnitude. So you just 64 plus 16 plus 4 plus 2. So equal to 86. So the answer is 86 in decimal. And for this number, it's a negative number because the sign is 1. So 0, 1, 0, 1, 0, 1, 0. So this is actually a two's complement. This two's complement. So the way they do it in this example, really, see that? Wait, so they just sum everything. 0, 1, 0, 1, 0, 1, 0. So this is 2, this is 8, this is 32, this is 128. So minus 128 plus 32 plus 8 plus 2 equal to minus 86. Okay, that's the signed numbers.
Yes, sir.
Okay, this is the summary. Different convention exists in binary system to represent whether a number is negative or positive. If it's sign magnitude, basically that if you have 8-bit number, so the 8th bit is the sign bit, the B7, because we start from B0. So this is the actual magnitude of binary. If one's complement, you look at the sign bit. If the sign bit is 0, then this is the magnitude, actual magnitude. If it's the sign bit is 1, then there is a one's complement. Okay. If it's a two's complement, the sign bit is 0, then this is the actual. If 1, then this is the two's complement. Right? Clear? Just look at the sign bit. If it's 0, then it's actual. If it's 1, then it's either in two's complement or one's complement, depending on what the question tell you. Now we go to hexadecimal numbers. The hexadecimal number system, what time is it now?
120 sir.
120, sir.
Almost 1 hour already, right?
Yes sir.
Okay.
2 hours.
120 sir.
120. So, you want to continue with hexadecimal?
No, sir.
No sir.
You want to stop? You want
Yes.
to stop?
Stop
Huh?
sir.
You want to stop?
Yes, sir.
Yes.
Okay.
Yes, sir.
Kita tak ada lagi sir.
Okay.
Nak hantam dulu sir yang ni.
Huh?
Dah biasa lagi.
Okay.
Ada sir yang beri ni.
Okay.
Saya nak mandi sir.
Okay. So we continue this later on next week lah. Next week. I will try. We are actually not consider we are ahead from the other class. The other class has not covered the op-amp yet.
Uish.
Okay.
Kita laju lah sir. Kita laju lah.
Laju sangat tu.
Laju lah sikit. Tak apa.
Apa sir?
At least apa ni, you have time to study for the first test.
Tu sir.
Yes,
Okay.
sir.
Okay sir, thank you sir.
Any question?
Thank you, sir.
If not, we stop here.
Selamat Hari Raya sir.
Selamat Hari Raya. So thank you.
Okay.
And I will stop the. I stopped the share already. So I'm going to stop the recording for this lecture. If you don't have any question, I will stop. Okay. Thank you.
Oh, sir.
Okay.
Thank you.